Hello, this is Dr. Randy Morris of IVF1, and this is Infertility TV on My Personal MD. Recently, the International Infertility Conference known as ESHRE wrapped up in Helsinki, Finland. ESHRE is the European Society of Human Reproduction and Embryology. Meetings such as this one allow physicians and scientists to present their latest research to their peers. These meetings can serve as an early indicator of which directions fertility treatment may go in the future, what new technologies may become valid treatments, and which ones were not able to withstand the rigors of scientific scrutiny. In today's special ESHRE episode, we are going to talk about selecting IVF embryos using mitochondrial DNA. Here's the question: what would IVF experts like me wish we were able to do? The answer: be able to accurately identify which embryos would produce a baby and which ones wouldn't. Turns out that's pretty hard to do, but we are getting better. In the beginning, we looked at embryos under the microscope. A decade later, we started looking for embryos with chromosome abnormalities. Initially, we could only look at 5 chromosomes. Now we can look at all 23 pairs of chromosomes. However, many embryos which look great under the microscope and have the normal number of chromosomes still don't produce a viable pregnancy. So the worldwide search is on for other methods to find healthy embryos. Okay, so it turns out that every cell has thousands of these little oval-shaped structures called mitochondria. Mitochondria produce the energy needed for a cell to function. Mitochondria have their own DNA and can duplicate themselves anytime. If a cell needs more energy, the mitochondria can increase their numbers to produce more energy. Some scientists have theorized that poor quality embryos need a large amount of energy as they try to make themselves better, and thus would have higher amounts of mitochondrial DNA. In fact, it was found that embryos from older women and embryos with chromosome abnormalities both had high levels of mitochondrial DNA. At ESHRE, Dr. Apida Ferjuli presented the results of a study she and her colleagues completed. They transferred a single embryo into the uterus of 111 women. Each embryo looked normal under the microscope and had the correct number of chromosomes. 70% of these women became pregnant. Every one of these embryos was then found to have low levels of mitochondrial DNA. The remaining 33% did not get pregnant, and 1/4 of those embryos had high levels of mitochondrial DNA. So the bottom line is this: if an embryo has low levels of mitochondrial DNA, it might produce a pregnancy or might not. But if it has high levels of mitochondrial DNA, it is very unlikely that it will produce a pregnancy. Mitochondrial DNA assessment might be the third method we use to screen out bad embryos and improve the chances that the ones we put into the uterus will produce a viable pregnancy. If you like this video, remember to like this video and share it in your support groups and on your favorite social media channels. Do you have a topic or question you would like answered on Infertility TV? Let us know in the comments. You don't want to miss any episodes, so subscribe to Infertility TV now and visit our website at ivf1.com.